Very good morning, students. I'm Chaitanya, Assistant Professor in Mathematics, Institute of Aeronautical Engineering, Freshman Engineering Department. Today, as a part of curriculum of third semester students, the Computer Science Engineering, Artificial Intelligence, and Machine Learning, we have we have a new paper which is being introduced in the R20 regulations. That is probabilistic modeling and statistical datasets. So we are going to discuss the probabilistic modeling and statistical datasets as a part of our course curriculum under third semester for CSE, AI and ML branch students. Okay, and this is a very new and also very important paper because the world we are witnessing today is about machine learning and artificial intelligence, and this paper teaches us the essential mathematics which we are going to use in the process of learning the artificial intelligence and machine learning concepts. Okay, so the first module in this title in this paper is principal component and analysis. Principal component analysis, which is a mathematical concept. That means in this paper, in brief, I could say that in this paper, the students are going to learn different mathematical concepts. Some concepts are related to matrices and some concepts are related to probabilistic modeling. Altogether, they will help you to develop some algorithms in machine learning and artificial intelligence. So, we are going to learn some essential mathematical concepts which will be very helpful in understanding the artificial intelligence and machine learning and also to develop algorithms in machine learning. Okay, so as a first module, we are going to start our discussion with the concept principal component analysis. That is the chapter name or title of the module, principal component analysis. Now, let us go to the next slide. Today, in this lecture, I am going to introduce the concept of dimensionality reduction. So, our major topic of interest is dimensionality reduction. And then we also discuss the emphasis or the role or the importance of dimensionality reduction in machine learning as well as artificial intelligence. So today we are going to discuss what is dimensionality reduction and how it is connected to mathematics, as well as what is the importance of dimensionality reduction in machine learning as well as artificial intelligence. That is the topic we are going to discuss today. Now, let us go to the next slide. Before going to the concept of dimensionality reduction, it is a courtesy to discuss about the introduction of artificial intelligence and machine learning. Let us have a brief idea about the artificial intelligence and machine learning. Are they interrelated or they are different? All these questions will be discussed initially. Then we'll go to the concept of dimensionality reduction and its emphasis on artificial intelligence and machine learning algorithms. Okay, right. See, if you see these Venn diagrams, you will observe that as per as the scientists concerned, as per as the computer data science experts concerned, artificial intelligence consists of machine learning as a subpart. So, machine learning is treated as a subpart of artificial intelligence, and in that machine learning, deep learning is treated as a subpart. So, in order to accomplish the artificial intelligence, we must have basically the idea of machine learning together with the idea of deep learning. That is what this diagram says. But with the next slide, we'll come to understand the more interactive relationship between these things. So let me move to the next slide. Here you can observe that there are three circles which are intersecting with each other: artificial intelligence and data science and the software engineering, the other software engineering. See, all these are interconnected. All these are interconnected, and we are observing that machine learning, machine learning is a common part of both artificial intelligence as well as the data science. So machine learning is important for both data scientists as well as the persons who are dealing with artificial intelligence, who are developing artificial intelligence. Okay, and with this diagram, we can also understand that artificial intelligence and machine learning are practically artificial intelligence and machine learning are not one a part of other or subset to each other, or one is superset, one is subset. It's not like that. Actually, development in artificial intelligence leads to the development in machine learning. Sorry. Development in the artificial intelligence leads to the development in machine learning, as well as the development in machine learning in turn leads to the development of artificial intelligence. That means whatever the developments or whatever the advancements we are going to see in artificial intelligence, they will automatically reflect an advancement in machine learning. And similarly, whenever the machine learning improves, automatically it leads to the improvement of artificial intelligence. So we can understand that artificial intelligence and machine learning both are intercircular. Both are inter-helpful. Artificial intelligence helps to the growth of machine learning, and in turn, machine learning helps to the growth of artificial intelligence. Let us see how the things go on between each other. Let us see with more detailed explanation, okay, with the help of next slides. Yes. So, here, first let us understand what is artificial intelligence. See, intelligence is a word related to human beings. Okay. So, in the entire earth, the human beings are treated as most intelligent living beings. Okay. But computers are machines. Computers are machines. They don't have intelligence. Computers don't have intelligence. Okay. So artificial intelligence is nothing but the process of training the computers to behave intelligent or to mimic the behavior of human beings. That means we are going to train the computers or machines to behave as intelligent as the human beings. Of course, it is not simple as we are telling. It is a very huge and complexified task, but we are trying to achieve that in a step-by-step method. We are in the initial stages of achieving the artificial intelligence, incorporating artificial intelligence into the computers. So artificial intelligence is nothing but the branch of computer science that consists of building intelligent smart machines capable of performing intelligent tasks. So we are going to train the robots or computers, whatever the machines, to behave intelligently. That means to make their own decisions just like the human beings do. That kind of science which deals of developing these kinds of intelligence is called artificial intelligence. Because why this is called artificial? Because the human beings behave intelligent naturally, but the machines are made to behave intelligent. That is why it is called artificial. Okay, and let us go to the next slide, where we'll see some applications of artificial intelligence. Let's go to the next slide, where we'll find some applications of artificial intelligence. Okay, so these are the recent updates about artificial intelligence. Microsoft is trying to crack the cancer code using artificial intelligence, because it understands that cancer is like a computer virus and can be solved by cracking the code. If you see that a virus is attacking a computer, you will first crack the code of computer virus, and you'll find the antidote. You'll find the antivirus. The similar way, Microsoft is also trying to crack the code of cancer, how it is how it is moving, how the cancer is spreading to cell from cell to a cell. It is trying to crack the code. Once it is able to crack the code, that would be easy for the medical world to find the complete solution for cancer, to find a perfect cure for the cancer. That is what. But in this process, Microsoft is taking the help of artificial intelligence. And in the same way, IBM is also doing some work in the name of Watson Oncology to find a cure for cancer. Okay, so these are some examples, recent developments in the artificial intelligence. Now let us question ourselves how artificial intelligence is different from natural intelligence. It means even though we make a machine which could behave intelligent, that means a machine artificial intelligence, it cannot be a human being. It cannot be equal to a human being. How a human being differs from a machine, even though the machine is incorporated with artificial intelligence. Here are the differences. Even though the machine is made to behave intelligent, it cannot be creative, because the creating and innovation skills should come by virtue, should come by nature. It cannot be trained. Okay, so a computer cannot acquire the skills of creation. Okay, creative skills cannot be incorporated into computer, so that is not possible, which is possible in human behavior. Humans can be creative, but machines can never be creative. Okay, and but through artificial intelligence, machine can be more precise in acquiring the results, in acquiring the answers, in finding the solutions to toughest mathematical problems, in solving toughest computer software issues. The machines could be most precise than the human beings, because human can error. To err is human. And consistency. A human being may not be consistent in throwing a ball into the basket while playing basketball. He cannot continuously throw 10 times accurately, but a trained robot can do that. So, consistency is an advantage of artificial intelligence to the machines, but a human being can never be consistent for all the time. Okay, at least one or two times he may fail. So that is why the non-consistency in the natural and multitasking. As a machine, it can perform multitasking, but human beings cannot perform multitasking due to the behavior constraints or the constraints of human behaviors. Okay, right. These are the basic differences between natural intelligence and artificial intelligence. Okay, right. Next, some applications where artificial intelligence is applied is banking. In the banking, with the advancements in the artificial intelligence, we can apply it in solving bank issues or bank disputes. Also, we can improve the transactional operations. We can improve the pace in the banking transactions. Okay, in organizing the operations, investing stocks, stock exchanges. Okay, managing properties becomes easy with the help of advancement of artificial intelligence and applying them in the finance world. In medicine has really with the advancement of artificial intelligence, we can find solutions to the most hazardous diseases like cancer and some more other non-curable diseases. Okay, with the help of artificial intelligence, machines are going to perform the operations in the future, just like our cataract operations. If you see, in the most cataract operations for eyes, most of the operations, most 90% are done with the help of machines. our participation of human beings, the human doctors, is only 10%. In the future, the machines or robots, trained robots, are going to perform most typical operations on the medical table with highest efficiency. Okay, where the human doctors may afraid to do those operations. Okay, now and similarly, there are we are going to expect so much developments in the fields of neurology, embryology, in so many fields of medicines in the future with the help with the advancement of artificial intelligence. Similarly, in social working sites also, they can automatically, like Facebook or WhatsApp, so many social networking sites automatically induce so many features which are to the customers by just with the help of artificial intelligence without much programming explicitly. Okay, without programming explicitly, with the day-to-day changes in the human likes, automatically they will induce new changes in their features, Facebook or WhatsApp, just with the help of artificial. They don't need to program explicitly. Okay, and robotics, the connection of artificial intelligence with robotics is going to be a major achievement in the forthcoming days. When the robotics are connected to artificial intelligence, through the sensors we can control the robotics, the behavior of robotics, and we can perform typical tasks in a easy way which human beings struggle to perform. Those kinds of tasks can be performed with the help of robotics. For example, as far as my intention is concerned, you know, even though we have developed, we are seeing so much of development in these days, the human beings are supposed to clean the septic tanks, and they used to participate in the sanitizations. They have to drown into the drainages and they have to clean. Even in these days, that is a pitiful thing. Why should a human is supposed to clean the drainages? Why a human being just like us is supposed to involve in cleaning those things, uh, sacrificing his health, his life, putting his life in danger? It's a very pitiful thing. So when the advancement of artificial intelligence, we can find a solution for those kind of things. With the help of machines, we can clean our drainages. With the help of machines, we can perform those things which human beings are not supposed to do. Okay, that is, and so many ways robotic connection with artificial going to bring more changes in our life. Of course, we are not going to too much detail because my perspective is to introduce the mathematical orientation of machine learning and artificial intelligence. Okay, so I'm moving to the next slide. See here, artificial intelligence is broadly categorized into three things: artificial narrow intelligence, first fundamental stage; artificial general intelligence, the next stage; and ultimate goal of artificial intelligence is artificial super intelligence. That means first we'll train the machines. That means these days we are trying the machines to acquire narrow intelligence. That means only small intelligence levels are being developed in the machines because it is very tough to behave like human beings. In the next level, after achieving this, we'll try to induce artificial general intelligence. General intelligence means they can we may make some robots which can talk like this, which can behave like that, like walking, talking, calling, singing, those kind of. And ultimate goal of super intelligence is the robots will exert their emotions just like human beings. They will also feel to love others, or they may also feel to hate others. They may also show angriness, all the kind of emotions. So slowly we want the goals of artificial intelligence is fundamentally narrow, then general, then super intelligence. But of course, achieving super intelligence will be a toughest task. So it is just now it is a nightmare for us. Okay, and machine learning, as a brief introduction, machine learning is without doubt the most known application of artificial intelligence. And the main idea behind machine learning giving system the power of automatically learning and improving the from its experience without being explicitly programmed. So first question is, sir, what is machine learning? What is machine learning? If anybody asks, what do you say? Machine learning doesn't mean that learning about the machine. We are not going learning about machine. Machine learning is nothing but making the machine to learn by itself. We are making the machine to learn by itself. That means machine can develop its own programs. Machine can program itself. That is called machine learning. We need not program a machine. We need not develop algorithm for machine. Machine is going to develop its own algorithm. Machine is going to develop its own program. That is what called machine learning. Machine learns by itself. So we are going to train the machines to learn by itself through their past experience and through the experience which they have acquired through previous algorithms and previous past programs. So with the similar kind of algorithms we have developed since few decades, we are giving so many algorithms to the computers in various situations. We are incorporating so many programs into the computer, so many algorithms. Now the machine will get when a new situation is given to the machine is going to develop its own algorithm depending by gathering the information from its previous experience. It will develop its own algorithm and it will develop the output from the input. Okay, that is what machine learning. And machine learning is a type of artificial intelligence that enables the machine to learn from the data and to deliver the predictive models. Predictive models means to deliver the outputs. So from the input, it is going to deliver the output without explicit programming. It will develop its own programming, it will develop its own algorithm, and it will sort out the issue. Okay. For that, it will take the help of artificial intelligence. The machine learning is not dependent on any explicit programming, but the data fed onto it. It will look into the data which is stored in it, and it will sort out all the data which is not needed, which is not concerned to the situation. It will collect the data, only that data which is suitable for the problem given to it, and from that data it will build its own algorithm and it will give the output. That is what you call machine learning. Based on the data you feed machine learning algorithm and training given to it, output is delivered. A predictive algorithm will create a predictive model. Automatically, it will develop its own algorithm and hence it will give its output. Deep learning is a subfield of machine learning that is concerned with algorithms inspired by the brain structure or functions of artificial neural networks. That means deep learning is nothing but more than machine learning. That means not only previous experience, it can develop its own algorithms by creating inside machine. We can create circuits inside the machine like that by using artificial neural networks. Artificial neural. If you see this diagram, in our brain we have so many neurons which are connecting so many parts of brain, right? So many parts of brains are connected with neurons and neuron cells and nerves. Similarly, we will in the deep learning we'll try to construct inside the computer. We'll try to build artificial neural network. With that, it will think. The machine will gain the power of thinking and developing a new algorithm by itself. Okay, and how machine learning differentiated from traditional learning. In the traditional learning, we used to program the computer. So the data will be given to the computer and handcrafted model, that is, a program will be inscribed into the computer. With the help of the data and program, the computer is going to deliver the result. That means this is data, this is program. We have infused the program, we have infused the data, and by using these two things, the computer will analyze and give the output. That is traditional programming. But machine learning is like this. First, we'll train the computer with the sample data to think, to develop its own algorithm, and and with this experiment it will give some output. And when the sample experiment is successful, when we give a new challenge, it automatically, with this experience, it will develop its own algorithm, and it will process it, and it will give the output. So here we will make the computer to learn by itself. A computer will learn by itself, and then it will apply its learning to find out the solution for the posed problem in front of it. Okay, right. That is called machine learning. Okay, traditionally computer will be programmed by human beings, but machine learning, computers are trying to program its own program. Okay, right. So when dealing with now our question, we are coming to the mathematical orientation. What is dimensionality reduction? When dealing with high dimensional data, it is often useful to reduce the dimensionality by projecting the data to a lower dimensional subspace which captures the essence. See, when there is larger sets of data, suppose when there is large sets of data given to the computer, okay, it becomes very tough for the computer to process, okay, and to develop the solution. So the computer will project the large sets of data into small sets of data by using dimensionality reduction techniques without losing the essence. That means without disturbing the essence, it will confine the data, it will concise the data, it will trim out the unnecessary things, and it will only preserve the necessary data, and with the necessary data it will produce the output. So that is called dimensionality. Dimensionality reduction is nothing but trimming out the unnecessary information, and with the help of available correct information we'll use it and we'll develop the solution. That is called dimensionality reduction, okay, which plays a major role in machine learning algorithms. So the number of input variables for a data set are referred to be features. Okay, number of input variables in a data set are called features, and the reducing of these number of variables or input variables is called dimensionality reduction. So dimensionality reduction is nothing but reducing the number of input variables. Okay, if there are 1 lakh variables, we'll try to reduce it to some 9075 variables by using dimensionality reduction techniques, so that the space will be reduced, the storage space will be saved, and time will be saved, and it will become easy for the computer to understand the data and to produce the results better. Dimensionality reduction refers to the techniques that reduce the number of input variables in the data set. More input features often make a predictive modeling task more challenging to the model, more generally referred as curse of dimensionality. If you have a lot of data is given to us, it becomes very tough for you to analyze the data, which is useful, which is not useful, to segregate and to find the solution for the problem. So by using dimensionality reduction programs, we can easily sort the data. We can take the data which is only useful to us, and from that data we can develop the solution. The curse of dimensionality is nothing but having large amounts of data in front of us. That is called curse of. The performance of machine algorithm can degrade with too many input variables. If as many as input variables, it decreases the performance of machine learning. If we have 1 lakh variables, automatically the machine learning algorithm will be weak. If you reduce them to 9000, like that, the efficiency of algorithm will increase. So that is why, to increase the efficiency of machine learning algorithm, we have to reduce the number of input variables. That is what we call dimensionality reduction. And if your data is represented using rows and columns in a spreadsheet, then the input variables are the columns that are fed as input a model to predict the target. Suppose your data on a spreadsheet, like this with rows and columns. Okay, each column represents a data variable. input variable x1, x2, x3 like that. Okay. So each column is called a data input variable or a feature, and your data sets can be preserved in the form of rows and columns. By using dimensionality reduction, we will concise the size of the matrix. That means we'll reduce the number of columns. We'll reduce the number of columns. Okay. From 12 columns, we'll reduce it to 6 columns or 4 columns, and hence it will become easy for us to analyze the data. And so, as a summary, dimensionality reduction, okay, to be effective with the machine learning techniques, we have to use high dimensional data. It will be very tough for us to be effective with machine learning. So we need dimensionality reduction, okay, to improve the accuracy and efficiency in the results, okay. And dimensionality reduction will help us precisely in 3 ways. It will improve the visualization. It will improve the quality of vision. That means it will improve the resolution, and we can see the things more with a more quality way. And also it will compress the data compression. Suppose compressing PDF. Suppose when the PDF is of size more than 25 MB, sometimes it may not be accepted by the receiver. So we'll try to compress the PDF. You know how to compress the PDF. There are so many algorithms available in the computers tools. With the help of tools, we'll compress this 25 MB into 5 MB or 6 MB, okay, without disturbing the essence, without disturbing the real information. We'll just by reducing little resolutions and trimming the edging data, okay, all this will compress the data, and we can reduce the size of the storage. And noise removal. When the data has so much noise, we can remove the noise with the help of dimensionality. So with the help of dimensionality reduction, we can improve the visualization, we can improve the quality of visualization, we can compress the data so that we can save our storage space, and we can remove the unnecessary noise involved in the data. So high dimensionality has many costs, redundant and irrelevant features degrade the performance of ML algorithms. Difficulty in interpretation and visualization may become infeasible due to the curse of dimensionality. Okay, these are all the advantages of dimensionality reduction. So you can see some applications of dimensionality reduction. Of course, machine learning applications, customer relationship, text mining, image retrieval, and speech recognition, handwritten digit recognition. You can distinguish between the digits which are handwritten and which are computerly typed. You can distinguish. You can recognize the speech who has really spoken, and you can image retrieval from the old photos. You can retrieve photo. You can retrieve a correct picture from the old data or old photos. Okay. These are all the advantages, applications of dimensionality reduction. Here finally I'd like to conclude the lecture with a small example. Here you are observing a data set of a picture, an image, okay, where the image is of each pixel. Here each pixel, pixel means a small dimension, okay, like a small rectangle connection. Each pixel is a feature. Okay, each pixel is treated as a feature. That means input variable. Now 28 by 28. This is the pixel size, 28 by 28. Here you observe that these borders are not necessary. Actually, information is only this diagram. Okay, the information is only this diagram. There is no important information in this black area. So you can trim out, you can reduce the space. You can trim out by using dimensionality reductions. You can reduce those unnecessary data. That is one example here. You can trim out the corners. You can only preserve this diagram, okay, with the help of dimensionality reduction. And also, the adjacent, the neighboring pixels can be merged without disturbing the essence of the figure. They can be merged. They can be pulled together without disturbing essence of the figure. That is also comes under dimensionality reduction. So this gives us an idea about dimensionality reduction. So in this dimensionality reduction, we'll apply so many mathematical concepts, especially matrices and some probabilistic concepts. So those things are going to be dealt in this particular paper called probabilistic modeling and principal statistical data sets. Okay, in the next lecture, we'll going to discuss the role of covariance matrix and principal component analysis. These topics are going to be discussed in the next lecture. So with this, I'd like to conclude my lecture for today, and thanks for your patience listening. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.